This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 83. We learn about a new member of the Ansys product family, AGI, from Paul Graziani, one of the founders, plus news and events from around the world of Ansys. Welcome to our podcast and welcome to the month of March. I'm Eric Miller, one of the owners of PADT and your host for this podcast. We hope everyone has made it through winter weather and is starting to see some signs of spring. I'm actually, if you can hear the birds in the background, recording this from the backyard of my house here in Phoenix, and the weather app says it is 75 degrees out right now. I apologize for any extra outdoor noises, but not for being outside. Now is our time here in the desert. We try to get out as much as we can and spend as much time enjoying the cool weather. In 4 months, I will be sitting in front of an air conditioner vent, and you will probably hear it over the microphone, even more annoyingly than the birds and the occasional power tool in the background. A quick look at the stats for the podcast show that we've had 25,994 downloads. So I'm guessing we'll hit 26,000 before this goes out on Monday. Please do subscribe through your favorite podcast app and also let others know about the podcast. We'd like to get more listeners out there if we could. Let's talk about our interview today. It's a good one. Last year, Ansys finalized their acquisition of AGI, Analytical Graphics, Inc. This is a big deal and will open up a lot of doors for anyone who, as you will learn, along with me, works on any product that travels through aerospace, air or space, and even across the ground. It's a pretty impressive set of tools, and I think it's going to do great stuff. I won't say any more. I'll just go to the interview and let Paul and Anthony share what they think. I want to welcome everybody to this special version of our podcast today. We have an interview about a very exciting new member of the Ansys family, AGI, or Analytical Graphics, Inc. And I'm very pleased today to have with me one of the co-founders of the company, Paul Graziani, and someone, Anthony Dawson, who is a product manager at Ansys, who has been on the podcast before and is a part of this integration. Hi, guys.
Hi, Eric.
Hey.
Good to see you guys. And you're both in Pittsburgh at Ansys headquarters, is that right?
Yeah, we're actually in Exton, Pennsylvania at AGI headquarters right now.
At AGI headquarters. Oh, okay.
Other side of Pennsylvania.
Other side of Pennsylvania. Well, to those of us who live in, west of the Rockies, it's all kind of just one big megapolis. So it's east, and I know it's cold. So I did come inside from my patio to do this recording because I didn't want to have the dogs barking. So we're really excited. If you follow the podcast, you follow Ansys, you know that there was an acquisition of AGI Analytical Graphics, and it really yet again brings something new and exciting to the Ansys family, and we want to learn more about it. And I think a great place to start, Paul, is if you can just give us a little bit of history of AGI, how you guys started and, some highlights of your journey. And then we'll talk a little bit more about what AGI does.
Sure. So we have a good hour for that, right, Eric?
Yeah, exactly.
That's
just
right.
A brief history of your life. Yes.
Right. Exactly. So we're 32 years old now. So we formed the core of the company came out of what's now Lockheed Martin right up the street. So a bunch of us were working there building ground systems for large government satellite programs. Mm-hmm. And in the course of doing that, we realized that we could take advantage of tools that if they existed to help us do analysis of the ground systems we were building, but they didn't exist. So we set out to build them on our own. We did that for a while inside of GE, but found that was just not the right environment to do that. That they are they were then and still are a large government contractor, and that's just the way they work. And doing things like using corporate money to develop tools just wasn't their thing. So three of us struck out. We were all just software developers, didn't know anything about business, and kind of quickly got thrown into the fire, so to speak. We quickly, fortunately, we were able to quickly start generating revenue. We developed our first product and had some sales of that within 6 months or so, and kind of bootstrapped the company like that. We were looking for external financing. We did get a venture capital a company to invest in us in about 6 years into the business. That went well until it didn't, but we nonetheless grew very substantially with that investment. We ended up buying them out about 10 years later, about 2005. Grew the business up, primarily focused on national security and space programs, and have expanded quite a bit since then into other areas. But that's more or less it.
Okay.
Go ahead.
No, that's great. And this is all taking place in Philadelphia mostly. That's where you guys have been mostly based? Correct.
About 220 of us total, with the majority of those here in this Philadelphia suburb.
Fantastic. That's a great journey, and kudos for taking the leap with no business background and making it work. I think that's fantastic. Good
yeah,
to hear.
It didn't seem so back then. There was just so much that we didn't know. And it was painful at times, and we were just very lucky to survive that period.
Well, it sounds. I think people I know who use the product. I think that's from what they've told me. That's why it solves a lot of problems and does a lot of things. So, let's talk about the product a little bit more. And before we started recording, I explained. I'm a Ansys user. I'm a mechanical engineer. I don't think from a system or a mission level as much as I probably should. So what really is digital mission engineering?
Sure. Let me start with the term. So we've struggled for pretty much most of our 3 decades to come up with a category for what it is that we do. We finally, drafting on companies like Ansys is using this digital engineering term, we started to realize that we do digital mission engineering, and that was really a big miss. If we look backwards at kind of one of the things that we really didn't do right, that's it, that we didn't define the category we were in. And instead, we just had this kind of very ill-defined presentation to the marketplace. And as such, we ended up just not helping nearly the fraction of the marketplace that we could otherwise. But I think that term digital mission engineering is terrific. I'll back up and explain how we got there. So what our products do is model things that move through space and time. We like to say we came from space, and that we started with satellites, and then missiles, which travel through space, or things like ICBMs travel through space, and then we quickly realized, and it always built our products all generically such that as long as it was an object moving through space and time, we'd be able to model it. Now, a satellite moves different than a missile, moves differently than an aircraft, moves differently than from a ground vehicle or a ship. And so each of those different domains requires a different set of tools to kind of help propagate those vehicles through those individual domains. However, just like all the coordinate systems, for instance, they're all the same. And environmental things like where's the sun and where's the moon, that's all the same. Where's the wind if it's down on the ground? All those things are the same. So we built out we built out this capability to model anything that moved through space and time, and then we, as those objects were moving in 6 degrees of freedom through space, we added in the capabilities that help. We use the term access, help determine access from one to the other. Now, the access might be like visible is kind of the easiest thing to think about. Okay. You might electro-optical camera, and you might need to know, well, when does that camera on a satellite or an aircraft or a ship see some other object? But that access also then extends to the RF domain. So it could be an antenna that's receiving a signal or transmitting a signal. It might be a radar that sends a signal out and bounces back. Might be hyperspectral sensor, whatever it is. So those were kind of the core functions. And then we built around that all of the things that an engineer or an analyst might need to help understand how all of that relates to each other. So an example of that, you might have a constellation of satellites, and each of those may have transmitters on board. Well, one of the things you need to know is collectively, how does that whole constellation deliver a particular communications mission over some area, and that area might be the entire globe, or it might be just a nation, or it might be some portion of the ocean. And so we have tools that allow our analysts and engineers to understand that across those multiple objects. So I could go on and on. It's 13 million lines of code.
I think, Eric, this from my perspective, from kind of the legacy Ansys perspective, when we first got to know AGI, and we announced, before the acquisition, those of you who are really paying attention, we announced a partnership with AGI about a year before we did the acquisition, a little more than that, I think. What was really helpful when we started to get to know AGI was the realization for me, exactly like Paul said, that, what does this software do? What is it really about from an engineering perspective? And at first, it seems like a very simple realization to go, oh, you're tracking objects in space and time. That's really all you're doing. You're tracking things around. And you think, well, that doesn't sound terribly complicated until you put it in the context of the applications that they're using it for, and what tools you have to present an engineer in order for them to be able to actually make use of that. And you realize, wow, it's mind-boggling that you can have, as Paul said, a satellite constellation with ground-based assets, maybe something out at sea, submarines, you name it, all of these things working and talking together and presenting a logical system for an engineer to make sense of that and actually plan the real world, plan missions with it in a best-in-class graphics environment to make it look realistic and really get a lot of value of it. And you go, okay, that's AGI. I get it. That's really valuable.
Yeah, so a little bit of legacy for me is my first engineering job was a summer intern at Lockheed Missiles in Sunnyvale.
Yep.
And I worked on, I don't know if you were aware of it at the time, SLC-SAT. It was a submarine laser communication satellite. And I designed the beam diverger for that. So if AGI had been around, or if I was younger and worked on that, I can see where it fits, right? Because one of the things that we really had to figure out is, could we focus that laser beam on where the submarine was about 100 feet under the water, and how big was and how intense was that beam? Given clouds and things like that, right?
Right.
So that was all basically hand calculated. I assume that's the sort of stuff I would use AGI.
Yeah, that's exactly right. And so the complexity, just one example. So you can imagine this laser beam, which is very narrow, trying to point to this submarine that generally don't like to tell you where they are.
Exactly.
So the pointing requirements are really incredibly difficult for that particular satellite system. So now there's all sorts of other things that come into play. Like, do you know exactly where that satellite is? Do you know exactly what the attitude of that satellite is? Do you know what else on that satellite might be, given a particular geometry, might be blocking that beam, et cetera?
Yeah, perfect. That's so cool. I bring that back in my memory. So that really, and I think the kind of the epiphany for me while you were talking was this: not just model the object as it's moving through space, but how they interact with each other, and how what sensors see and what they do, how you point sensors, what they could do. So that to me is a big epiphany, is thinking about that information transfer between objects or stationary things out there. So okay, that's really cool. I always think of AGI. So I ran into AGI at the Space Symposium in Colorado, I think, for the first time at your booth there, and got kind of familiar with it right before the Ansys started partnering with you guys. But I always think of you guys as satellites. So you mentioned a little bit. What other areas do people use AGI in, and what's the most common of those?
Sure. Well, space always has been, I suspect for a long time, will be a really important part of what it is that we do. But we do a tremendous amount on aircraft, and those are both manned and unmanned aircraft. So take unmanned aerial vehicles. The Global Hawk system, for instance, uses us for mission planning on that particular system. You look at a bunch of aircraft like the RC-135 rivet joints who need to do mission planning or combat sent aircraft. That's an aircraft that needs to monitor adversarial or radar systems, and so we'll do things for them like model the beam of a particular radar, and then allow the operators of that aircraft to fly down that beam for as long a period of time as possible. So aircraft certainly big ones, and missiles, pretty much all sorts, intercontinental ballistic missiles from both sides. Most recently, hypersonics have been a big issue. You've probably read in the press, both the Chinese and the Russians coming out with hypersonic weapons, and so modeling those are kind of right in our sweet spot. And then so I'd say if you look at it from the users, it's probably space first, then aircraft, and then probably ships, and then lastly ground vehicles. But it's really across that full spectrum.
I was going to ask about ground vehicles because, of course, we're seeing a lot of growth. PADT is, as well as all of Ansys, with autonomous vehicle development. And so does AGI play a role in that sort of thing as well?
Yeah, we do. As I mentioned, it's probably one of the smallest areas for us ever, especially in autonomous domains. So these features are the same features that get used by our satellite aircraft. However, if you look at an autonomous car, obviously sensors and what those sensors can see and how they move as the car either kind of goes down a road, and it might everything from hit a bump, for instance, and then that sensor might jiggle in a particular way that might be very difficult for, let's say it was a sonar or something that was trying to reflect sounds off of nearby cars. That's right in our sweet spot there. Not a tremendous number of users there, but the applications are great. It is one of the things that we are pretty excited about, the teaming up with Ansys. We had our hands full. The space market is very large. The aircraft business is very large, and we were really mostly focused, as I said, on national security and space. So, but these other marketplaces like autonomous cars are huge, and we're very anxious to get out and get more involved with that, and think we can do that with Ansys.
Fantastic. That's fantastic. It's making me, now that I got a little bit better view of what it does, it's making me think of all these different things that would be applicable. So really a question for both of you from each of your perspectives. What are you most excited about when it comes to integrating with the Ansys product family?
Well, I'll go first. I think that what excited us from the beginning of the partnership all the way through to push towards acquisition and now is, for me, it was the realization that AGI customers were using AGI tools to do broad digital mission engineering, and that oftentimes they had the need for physics understanding, physics analysis of elements and components of those missions, and we're either allowing that need to go unmet, or we're using overly simplistic heuristics models or overly simplistic, just basic fundamentals models without actually getting into simulation. And we validated that during the diligence, during our due diligence process for the acquisition, by talking to many AGI customers, about our partnership, and every single one of them said, we do that type of, we do that type of analysis with basic tools. We would love to get more fidelity around that. And it was, very exciting to hear them not only say, yes, we would like to use Ansys in the future for something like that, but say things like, can you get us a demo? Can you get us some software to try?
That's a good indicator. Yeah.
So we see a lot of potential there for just the basic bread and butter use case of Ansys physics simulation, simulating components of the mission to provide detail, right in there. along with things like autonomy and other aspects that Paul just mentioned, that we see great long-term potential for AGI to help augment Ansys' solutions in those applications and areas.
Right. Yeah, no, I agree very much, Anthony. And I'll actually, my answers here, multiple, will kind of follow along. If we go like Anthony, the way I think about what Anthony just said, this would allow, the merger really allows our customers to now have much more direct access and understand how Ansys' tools can drive down to this higher degree of fidelity in deeper areas than we've been able to take them. So, for instance, a great example of that would be our communications modeling. So for us, we will model an antenna, and we've got a handful of parameters that we can put on that antenna that might exist on an aircraft or a satellite or anything, a vehicle, car rather. So what HFSS allows us to do is to model in much higher degree of fidelity kind of what that antenna, how it would actually perform in near term and far term ways that then will augment our analysis to give us a more precise answer than we would otherwise. So that's kind of one dimension. Mm-hmm. Another way, again, and this overlaps a lot with what Anthony just said, but if you imagine this from a user's perspective, a stack that exists that might go from a chip level, a chip on a circuit board in a component in a subsystem, and then in a full system, and then that system operates in a system of systems. Mm-hmm. And now, I think what's really exciting is that engineers and analysts all up and down that stack can understand how the engineering trade-offs that they're making along each of those affects the mission. So if I change a heat sink, for instance, what is that going to do to the mission? If let's say it's a chip on a navigation system in an unmanned aerial system, and now that system is out operating in maybe a hot area, and it's in the sunlight. And now we can see that that navigation system is going to start to overheat. And what's that going to do to the positional accuracy of where that unmanned aerial system is? And what's that going to do to that mission that system's performing, as an example? So I think that's to me kind of what's really exciting about that. And then the other point that Anthony was making there, the opportunity to then branch outside of national security and space to these other marketplaces is really very exciting from our perspective.
Yeah. Yeah. Well, I can tell you from experience of, I lost count of how many acquisitions I've been through with Ansys. The first one was that I was really involved with was the ISM CFD folks. It goes well. It's not easy to take new technologies and integrate it with an existing family, but it's always pretty much turned out in a positive way. And so I really want to, on behalf of those of us who sell and support and use the tool, welcome you to the family, and we look forward to that, slow and very deliberate progress of doing that integration, because I think the more I listen, the more excited I get about how this is going to help all of us and we all work on mostly we work on stuff that moves through space. So
we're excited. We're excited from the Ansys side about exactly as you said. The long-term change to what we offer as a company now is super exciting. And an example, we have a standard PowerPoint slideware that we give out to our account managers to go talk to people about. And in there's a slide that we call our technology stack that takes people through kind of the different physics offerings we have, and then the, kind of the platform offerings and materials and, things like our simulation data management, and then maybe our digital twin offerings and all. And it's really exciting that we've just recently kind of rebuilt that slide to incorporate AGI. And we have this entirely new layer across everything on the top that's basically, missions. What about when you deploy these products that you are designing and analyzing with Ansys and actually put them in the real world and have to figure out how they go and actually become operational? we have software now that, regardless of pretty much anything you're doing, you can simulate deployment in the real world in a much more realistic fashion, and that's just exciting for Ansys to go to a new level.
Yeah. That idea of digital testing or virtual testing in a whole new realm. It is exciting. I'm stoked. We get to, I want, and I'm really resisting getting into the weeds on some of this stuff, but I just wanted to get kind of an overview of the product and where things are going. Is there anything I didn't ask that you'd like to share with our listeners?
One thing that comes to my mind is just the the maturity that AGI has in dealing with the aerospace and defense sector, and dealing with aerospace engineering is also very exciting for Ansys. Eric, you're well familiar that Ansys, if you think of a typical college campus and all the different engineering departments there, Ansys is very strong with a lot of those departments. But one area that we never really had a great presence with was aerospace engineers.
Right.
Certainly some elements for using our design tools for various things that aerospace engineers work on. But holistically, it was a bit of a blind spot to us, and that is obviously AGI's core strength. And so when I think of the college campus view of the engineering world, it's really exciting to have picked off another building. We got the aerospace building now in our quarters.
Yeah, exactly right. Exactly right. It's fantastic. And, we've been doing this campaign around the new meshing capability in HFSS, chip to chip. And I think it needs to go further. It needs to go chip to the system, right? The whole, the solar system, right? We can go that whole spectrum now. Even I assume people are using it on interplanetary missions as well, right?
Oh yes, very much so. One of our suites. It's pretty much all of those missions that you see. That area, the interplanetary area, you really start to narrow down the set of tools that are available, and pretty much all of those use our products. One of the things I'm most proud of, the New Horizons mission that went out to Pluto, was an incredibly complex trajectory there. So the spacecraft, the booster lifted off. They went right past the moon, went to Jupiter, used Jupiter as a swing by to then go to Pluto. Normally on those missions, they plan for intermediate adjustments to that trajectory. It turns out they didn't need any. It was absolutely dead on right from the beginning, which is really hard to do. So yeah, that's an interesting area. You see certainly a lot of lunar missions now in the press, and then Mars missions certainly, and we're going to start seeing more and more missions to asteroids, and again the value of being able to model accurately how to get there, how to model things like I'm now going to arrive at this asteroid. It's a strange shaped thing. It's very hard to orbit around, for instance, because they don't have that much mass, therefore they don't have that much gravity. And the mass is distributed typically in a weird way, so the orbits are very wonky. And typically there are imaging of those things, and they're not just close to spheres like the Earth is. And so it's difficult to figure out how to image, and if you're going to touch down, where you're going to touch down. So all those kind of things are right in our sweet spot.
Do that virtual, the what if stuff before you commit. That's really, really cool. Well, I look forward to learning more. Now, if our listeners want to learn more, Anthony, what's the best way for them to kind of, besides just reaching out to your Ansys, well, even at this point, reaching out to your Ansys salesperson may not be the best way to start. What's the best way to learn more about the AGI product family?
Well, first and foremost, let me say it's always a good idea to reach out to your Ansys. But if you want more specific information on AGI, really the best place, is often the case, is Google AGI and go to their website. Their website is still up and running. It's got some Ansys branding on there, but for the most part, it's really what it was before. It's a great website. It'll talk you through the headline products that AGI offers, exactly what they do. You see really good, example use case applications, all that. And then when you go deeper, if you do reach out to an account manager, we have this great treasure chest of application examples that we can walk anybody through that show examples of using AGI and Ansys technology together. We touched on just a couple of the huge huge bank of them that we've got. And pretty much, regardless of whatever Ansys tool you're using in your application, we can probably show you something that'll excite you and help think about how AGI software can be used alongside with Ansys to really open up new doors.
Anthony, I'll add to that, Eric, our YouTube site. So if you go to AGI YouTube, what you'll find there, just hundreds of videos that span, it's everything from very quick little how-tos. There's full-up training sessions, webinars in there, all sorts of great content searchable that should get a lot of your listeners to the thing that will help them understand what it is that AGI does and what it is that AGI and Ansys do together.
Yeah, that's a really good point. I've looked at a couple of those, and it's not, simplified cartoons. These are beautiful graphics that you get in the product and very realistic looking. So that's a great idea. I do encourage people to take a look at those to get a feel for the product and what it can do. I can't wait to learn more and go down this journey with you guys. PADT has talked to some of those experts over at AGI on some joint accounts that we have, and I know that our salespeople and technical people have been really excited about that conversation that we've been having. So I think it's just going to get better and better. So once again, we're adding to the family, and it's good stuff. So I really appreciate your time, guys.
Great.
Yep. Thanks, Eric.
Thanks so much, Eric.
All right. Well, stay warm out there and stay safe. And hopefully next year for the sales kickoff, I'll be able to see both of you guys in person.
That would be good.
All right. Thanks a lot, guys.
Thanks.
Bye-bye.
Bye-bye.
Bye.
Welcome back. I want to thank Anthony and Paul for coming on and educating me. As you can see, this is really a whole new area for many of us, but an area that your company may already be involved in. And it's another step towards this idea of pervasive engineering with the Ansys suite of tools. So really taking it to a new level on that stack of where things go and overarching, literally, in some cases, where we are now. As Anthony said, their website is really good. Check it out. You can learn a lot about the tool there. And I also did check out some of the videos after we recorded the interview that Paul suggested, and those are also really informative as well as entertaining. Go ahead and just go to YouTube and search for AGI, then space Ansys. That's how I found them. They have a channel called AGI and Ansys Company, so that's the best way to get there. And I also found they have a series, which I really like, called AGI Geeks, and it's kind of their technical support people talking about aspects of the tool. I found those very informative and gave a real good look at kind of into the weeds on some of the things, so good stuff. And now it's time to do our commercial. And it's going to be a short one today. When was the last time you sat down and did an assessment of what Ansys licenses you have? You do it for your stock portfolio, or at least you should. You do it every time you look in the fridge. Why not for what may be the most important tools your company's engineering groups or departments own? Reach out to your Ansys professional. Hopefully it's someone here at PADT, but if not, that's okay. And set up a time to look at what you have and, more importantly, what you don't have. Time to add some Sherlock? Maybe you can stop outsourcing CFD and get Fluent in-house. If you listen to the podcast, you know Ansys is adding new features, modules, and full programs all the time. Take a look at what you need and see where Ansys can help you solve more problems. And next up is the Ansys stock. So we'll go really quick since I was late last week. We actually put the podcast out about 5 days late, and so I did. It's been a week since I looked at the stock, so we'll go really quick through this. It's down again for the week. It's down to 309.60. That was at 3:23 Eastern on the 5th of March, 2021. That puts it down about 15% year to date. Where the S&P 500 is pretty much flat at a 2.1% jump today. PTC, just as comparison, is up 4.5%. Altair is flat at what was, when I looked at the numbers, is 0.1%. So definitely flat year to date. And then Autodesk is more along the same trajectory of Ansys. It's down 12.5% so far in 2021. There's no corporate news from Ansys, so we won't report on that. We do have some PADT news. I may have covered this in the past, but I don't think I did, so let me just bring it up right now. The first is that we have a new VP of Sales and Support here at PADT. His name is Jim Sanford. He has a long history with tools for engineers, first as an engineer himself using them, and then working as an application engineer, and then getting into sales and sales management. You may have run into him in your career. He's been around for a while and even worked for a few of our competitors in the past. We're excited to have him help us out and take our sales and support capabilities to the next level. We'll try and schedule a time for him to come on the podcast after he's been here for 6 months or so. So he's kind of settled in and can share with you what he thinks about this world of PADT and this world of, more importantly for the podcast, the world of Ansys. Also, you may hear this before the press release goes out, so this is a scoop, but PADT is now a diamond reseller for Stratasys. This is their highest level for their channel and is a testament to the high quality of the sales and support that we offer our 3D printing customers. So hopefully some of you are not just Ansys users and customers of PADT, but also Stratasys. So we're really pleased to have been given that honor. Taking a look at publications, the Ansys blog had some really good ones over the last couple of weeks. So I picked my 3 top. My favorite is called Winning the War on COVID with Ansys Fluent. And it's some more examples. We talked about this quite a bit through this whole pandemic. This is some new examples of using Ansys Fluent, since this is an airborne disease, understanding how air moves around in a closed area, a room, is really important. So they got an example of a soccer stadium, I think it is. It could be football, American football, I can't remember, and also a fitness center. So very useful and something you might be able to share with some of your folks who aren't simulation, people who aren't simulation users, to say, well, this is what we use simulation for. They also did a whole series of articles. There are 3 or 4 of them that were like top 2, top 3 new features. The ones I like the one on mechanical, OptiSlang, and HFSS. There's one for each of those. So do check those out. Even if you're not a user of those, it's good to know what's new. We can talk about it here on the podcast as well. But it's good to get the perspective. And then the last one was called Women in Technology, Cybersecurity Expert on Why Diversity in the Industry is Important. And I found it an insightful look from the perspective of a female working in tech of why diversity, not just men versus women, but also different kinds of diversity, can make a real big difference in the industry. And something that we've certainly seen here at PADT. And I thought her insight and perspective was really good. Looking at the PADT blog, we have put out 2 things recently. The first is part 2 of Alex's article on alternating stresses. It's called Alternating Stresses in Ansys Mechanical. Part 2, von Mises stresses. So he takes a look at how Ansys calculates von Mises stresses when an alternating stress situation. Signs tend to go away when that happens, and how to do that. Very good deep math there. So check that out. And then Miles did a really fun one. He did a travel trailer analysis in Ansys Discovery. So he used Ansys Discovery to very quickly understand why the sides of a friend's admittedly cheap travel trailer got sucked off. I guess they kind of got loose and this kind of came off. And what he did is he used very quickly modeled it in Discovery and was able to see that the way the air moved around the truck and then around the trailer, it created negative pressure on the sides of the trailer that eventually obviously caused it to come off. And then he did some really quick CAD to put some turbulators on the top and see what that did. And putting turbulators on the top of the trailer actually impacts the flow around the sides of the trailer in a positive way, creating a positive pressure. So check that out. It's a fun and actually useful example of using Discovery to very quickly understand something. Next up is events. Taking a look at the PADT event calendar, which is at padtinc.com/events. We've got quite a bit going on now in March. The next upcoming event is on the 10th of March. It's the State of Mechanical Meshing and Ansys 2021 R1. That's always one of our most popular. Meshing is always a popular topic, so do check that out. Then on the 11th, the following day, we've got actually 3 events all focused on automotive simulation, and 3D printing. So the first is at 10:30, and all these are going to be recorded. But if you want to attend live and ask questions, you can. It's called The State of Additive in the Automotive Industry, and it is basically a look at how people are using additive manufacturing in the automotive space. Then at 1, we have kind of the same thing, but it's called Simulating the Future of Automotive Industry. And it's about using simulation in the automotive industry. And a lot is going on there, as we've talked about in the podcast. And then we wrap it all up at 2:30 with a panel discussion with the folks that talked from Stratasys and Ansys and PADT and some customers at 2:30 to 3:30. These are all Arizona times, Mountain Time, it's called Innovating. It's a panel discussion on these topics, actually. So it's the same name. Do check those out on our website. You can go, like I said, to the /events and register there. And they're also going to be in Bright Talk as well. So you can register directly in Bright Talk if you're used to doing that. Then we are doing something with Stratasys that you may be interested in attending if you're listening from Texas. Stratasys basically outfitted a semi-trailer with a bunch of very cool state-of-the-art 3D printers, and they're driving around the country and showing off the stuff in a socially distanced way, one person at a time, masks, et cetera, et cetera. It's a really cool way to get and see all these new printers and the parts that they make. So we're going to be in Houston on the 18th, San Antonio on the 22nd, Austin on the 25th, and finishing up for Texas on the 30th in Dallas. So, it sounds like a concert tour, right? These are the 4 cities across Texas that they're doing. So, again, go to our events page to check that out. Stratasys has got a lot of cool stuff going on. Do see what's new. I will also bring up that Ansys Simulation World, as we've talked about on the podcast before, for 2021 is going to be on April 20th and 21st, and you can register for that. Please do go to our website, events, and click on the register button there, because we get credit when you do that, and we get brownie points. So if you're a fan of the podcast, throw some brownie points our way by using our link to register for Simulation World. We did hear back. A few of Ansys's employees will be presenting, as well as a couple customers. So we're very excited about being part of it, not just as participants, but also as presenters in the 2021 event. So that is it for our events and webinars and such. So I want to thank, and for our podcast as a garbage truck goes by, and if you heard that, thank you. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in. Spread the word, subscribe to the podcast, and as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 83. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.